Smart factory solutions for any mix, any volume. Total integrated solutions, allowing you to focus on your business while we manage your production challenges.
Welcome to the Promation booth here at APEX. I'm delighted to be joined by Mike Goldberg, who's, I don't know, are you the co-president? Because I know your dad's the president. So
yeah, I call myself the co-pilot these days.
Co-pilot, okay. So, Mike, we're standing in front of your latest automatic robotic soldering system. Please tell us, our readers, a little bit about it and some of the many features that you've got built into it.
Yeah, so the Quick 9440 IRU system is the proud recipient of this year's NPI Award, the New Product Innovation Award.
Congratulations.
Thank you, thank you. Some of the features that make the system a little bit more unique as opposed to previous models is that we've integrated some new technology to ultimately aid in overall process stability. One of the things, of course, very pronounced on the system is the integrated IR bottom side preheater. Right. This system was truly designed for heavy thermal dissipative products that require, that are thermally challenging to the common tabletop soldering system. Here we've got a Forzine IR preheat station. We've got infrared laser probes that will come down and actually monitor PCB temperature, dynamically offset the program to allow for increased preheating time, as well as halt the program or pause the program to elevate PCB temperature at loss or dissipation of that heat. Right.
Now I notice it's in like 8 zones, the preheats under there. So can you highlight some of the zones where the heat is required and leave out other zones, or how do you do that?
Yeah, the zones are completely selectable. So for smaller PCBs, there's no sense in the going green factor. We'd like to make sure that we're making the most of our operating costs, right? And so the idea is that yes, while we can run all 4 zones, the idea is that it's selectable. We're running a smaller PCB. We can really more specifically drive heat to that smaller PCB without being so wasteful of the energy nowadays, which I know is quite big out here in San Diego, California.
Absolutely. Okay. So, and 4 lasers that measure the temperature at any given time. You've also got something that deals with board warpage.
Yeah, so understanding that specifically with thermal profiling of boards under the expansion and contraction of certain materials, we understand that there can be board warpage, or in many cases we often get the example through power supplies where we're loading heavy coil packs, onto the board, that we can get board saggage, or again, board warpage, should the supplier not be super keen and attentive when manufacturing the board. The idea on this system here is that we've included a tip pressure monitoring system. So understanding, for our listeners out there that understand motion control platforms, we typically have an X, Y, Z, and theta coordinate. It's a static coordinate. Right. A robot does a very repeatable test, and it does that test very well to a very specific coordinate, again, X, Y, Z, and theta. The concept here is that we've taken a static coordinate, the Z-axis, and actually elevated it to a dynamic coordinate. So the concept on this system is that with our tip pressure monitoring, we have a newtons of force lower limit and an upper limit, which allows the user basically to specify a set pressure range. So in the instance where we're soldering a component that may be more in the center of the board that's really sagging, is the board will disregard more or less that static coordinate and continue dynamically continuing its movement. Correct, until we detect that set pressure, ultimately aiding in overall process stability.
Right. Okay, well that's pretty useful because it is a common problem. So let's talk about the soldering itself, or the soldering itself. What have we got here in terms of the valve configuration?
Well, again, this unit is really feature rich, and I say that in the most common sense of the term. Here we've got an integrated heated nitrogen output kit. Through our nitrogen generator, we can run a compressed air line, generate that nitrogen at a 99.9% purity. We actually input that right into our soldering iron here. Just to put it in perspective, the nitrogen comes out heated. If we're soldering at a nominal temperature of 430 degrees Celsius, the nitrogen's approximately coming out at around 174 degrees Celsius. Okay. Based upon different diameters or bores of this N2 sleeve here, we can get a higher concentration or less concentration with an overall spread. So what this means is that if we're soldering a row of header pins, for example, we can get a preheat effect across those pins to allow for more expeditious or expedited soldering.
Right.
Additionally, on the system, we've made a few upgrades, such as the new solder wire output feed bracket, a little bit more fine-tuning involved there for the end user. Additionally, we've upgraded the solder feeder, which is really a pronounced feature on this new system. The concept behind that innovation was really for applications that require a higher degree of rotation. We have really shortened almost by half the distance from the actual feeder to the soldering iron.
Okay.
What happens is if end users weren't necessarily very attentive or careful with making sure the feed tube diameter is really to size, we get built up pressure, which can ultimately, under rotation, lead to pistoning of that solder wire in and out. So by reducing the length, we actually allowed for more true volumetric indexing of that solder wire, ultimately, again, leading in ultimate precision and accuracy and process stability and control.
Okay, that's smart, that's smart. So what about teaching the system? How easy is that?
Well, teaching the system is really the same as it's been across the multitude of our different configurations. It is a point-and-teach system. Whether you're, again, buying into the technology at an affordable level, at a very base or, again, affordable level, up to our higher-end systems, rotary table and inline solutions, it's really all programmed the same way. So for the entry-level manufacturer who's looking to make a solid investment in automation, it's a one-time learning curve, and really as they expand, and we hope, as with any company, they continue to perform and do well, really there's no additional training curve needed. They can pick up a more advanced solution and be programming the same way, very much as how they're used to with an entry-level system.
Okay, okay. Now I notice you've also got a security system built in here with this wand type security on the sides here. How does that work? Does it automatically cut out when people put their hands beyond this point, or does it have variations?
Of course, operator safety first and foremost, right, Trevor? So yes, we have a few different options that are configurable through the system. Most common here in the US is going to be, as soon as we detect an intrusion, we're going to halt the robot, ensuring operator safety first and foremost. There are additional options, which are complete the actual solder joint as to not necessarily burn or damage the product, more or less completing that cycle. And then we also have a delay setting in which you can simply program a delay to say how soon you would like it to halt. Most common here in US, we like to maintain the safety for the operator, so we immediately halt. Whether we're destroying the product or not, we sure as heck don't want to cause harm to the operator.
Okay, I understand that. So it's a fairly robust system. I mean, it's quite a chunky machine. I believe you've built in some stability into the base of the system.
Yeah, truth be told, this thing's a powerhouse. It's beautifully engineered. We've got tempered glass surrounding the system, again, leading to that operator safety. There's nothing that can really get in there. It does have quite a bit of weight, which is a good thing, of course. We'd like to make sure that the machine is durable and has years of lifetime left to it.
Yeah.
Absolutely, yeah. Of course, we never want the robot really shifting, during the soldering operation, which can lead to different flow out and different wetting defects. So we like to make sure that it's a robustly built system, operator safety, feature rich, and ultimately at a very affordable and very attractive price.
I'm sure it is. We don't talk prices here, but okay. So I believe you have another machine on the other side of the booth here, Mike, that has got some special features to it. Can you tell us a bit about that?
Yeah, so we've taken our true most popular and best-selling unit and we've really updated that to include some of the latest technology available. The main difference on this 9494F system is the increased diameter on the Z-axis shaft, which really leads to, again, ultimate stability in our Z-axis movement with integration of our tip pressure monitoring system, as well as offers the advantage for that new high-rotation solder feeder. So a very, again, attractive system, good looking and performs well. What more could you ask for?
Okay, well, it runs in the family. Okay, Mike, thank you very much for showing us the new products here on the Promation booth, and thank you for best of luck with the new systems.
As always, my pleasure, Trevor.